The last lesson in Unit 2, and we're going to talk about how to calculate and find a greatest common factor and least common multiple. And I feel like this is something that always tends to get confused, the difference in the two between the students. But I feel like if we do a really good job at teaching what a factor is, what a divisor is, and what a multiple is, then this is much easier for them to understand. So the greatest common divisor, also referred to as the greatest common factor of any two integers, and I could even give you three integers, but between any two or three integers is the largest integer that divides both of them. And if you've taken college algebra, then you've done this when you've factored out the greatest common factor. But basically, if I give you any two numbers or any three numbers, this is the number that is the largest number that divides both of the numbers. The least common multiple is when you consider all the multiples of the numbers, and the least common multiple is the smallest multiple of both of the numbers. And so basically you consider multiples of each number, and whatever is the smallest multiple that they have in common is the least common multiple. And we're going to do several examples for both of these definitions to really, reiterate what they mean. The definition of relatively prime is when the two numbers that are being considered, the only divisor that they have in common is 1. So for example, 4 and 9 are considered to be relatively prime because the only thing that both of them are divisible by in common is 1, and that makes these numbers together relatively prime, meaning the greatest common factor of these two numbers is 1. Now we're going to work on finding the greatest common factor or divisor and the least common multiple by two methods. And I'm first going to show you the intersection method, and then I will follow up with the prime factorization method. The intersection method works best when you have numbers that are smaller. And so I would say, numbers maybe smaller than 40. I would do maybe this intersection method. When you have numbers bigger than that, it's going to be more efficient for you to use the prime factorization method. You can interchange these methods. If there's one that you really like, you can use it on even larger numbers or smaller numbers. But I have just found that the intersection of sets method works best when the numbers tend to be smaller, and the prime factorization method is going to work best for you. It's going to be more efficient with larger numbers. So to do the intersection of sets method, I've listed out the steps for you. So to find the greatest common divisor of any two numbers, you will list all of the divisors of each separate number. And then you're going to look at the sets of all of the common divisors, and you are going to identify the greatest divisor that is in both of those lists. To find the least common multiple, you're going to write out multiples of each of the integers, and you're going to do that until you find a common multiple, and the smallest multiple that is a multiple to both of the integers is what we would call the smallest multiple that they have in common. So for this first example, the two integers that I'm giving you is 24 and 36. Over here on this first side, we are going to find the greatest common divisor, and then over here we'll find the least common multiple. And it's two separate calculations. So to find the greatest common divisor, you can come up here and refer to these steps. But what you're going to do is you're going to write a set. Basically, you're going to make a list of every divisor of each of the two integers. And sometimes I might even give you a third integer, like that would look like 24, 36, and 12 maybe. But for now, we're going to start with 2. So what we're going to list first is divisors of 24. And I'm going to write it in set notation. We've done that in Unit 1. And I'm just going to list every integer that 24 is divisible by. So the positive integers. So 24 is divisible by 1, 2, 3, 4, 6, 8. You just start with 1 and go up, and is 24 divisible by this? Is it divisible by 1? Is it divisible by 2, 3, 4, not 5, 6, 8, after 8 would be 12, and after 12 would be 24. And that's why this works best when you have small numbers, because it's easy to make a list of everything it's divisible by. If your numbers start getting larger, then it makes it harder to make a list of everything it's divisible by. Next, I'm going to make a list of the divisors of 36 in a set notation. So 36 is divisible by 1 and 2 and 3 and 4, not 5, is by 6, not 7, not 8, but it is divisible by 9, not 10 or 11, but it is divisible by 12, not 13, not 14, not 15, not 16, not 17, but it is divisible by 18, because 18 times 2 is 36. And then finally, after 18, the only other thing it's divisible by is 36 itself. So all I've done is I have listed all of the factors of 24 and 36. And the greatest common factor, or the greatest common divisor, the word greatest is the key here. It is the largest number that these sets have in common. So basically, it's the intersection of the sets, what they have in common, but it's the largest thing they have in common. So when we compare these two sets, I'm looking for the greatest number that's in both sets. And when I make that comparison, it's 12. And so we would say the greatest common divisor of 24 and 36 is 12. 12 is the largest number that 24 and 36 are both divisible by. Greatest common divisor, the largest number they're both divisible by. The least common multiple is a completely different calculation. So we're going to do multiples of 24 now. And remember, your multiples are 24 times 1, 24 times 2, 24 times 3. We've already addressed that in this chapter. So multiples of 24, we're just going to make a list. We'll keep going, but we'll start with 24 times 1 is 24. 24 times 2, sorry, my pen is freezing, is 48. 24 times 3 is 72. And we're just going to keep adding 24 every time. So then we get to 96. After 96, another 24 would be 120. Another 24 would be 144. And then I'm going to do ... because, we could keep listing forever. But we're actually looking for the smallest common multiple. So maybe we're already there. Now we're going to go ahead and write multiples of 36. So 36 times 1 is 36, times 2 is 72, times 3, 36 times 3 would be 108. You're just adding another 36 every time. Another 36 would be 144, ... And I'm going to stop there because I already recognize some common multiples. Now, in both lists, I see 72 and 144. Yes, 144 is a common multiple, but for this particular calculation, we're looking for the least common multiple, the smallest common multiple of 24 and 36. So the smallest common multiple of 24 and 36 would be 72, because that is the smallest multiple that appears in both lists, in both sets. So this is called the intersection method because it's the intersection of the two sets. It's what the two sets have in common, which we worked with in Unit 1. Finding the intersection of two sets is what they have in common. And then being specific of what's the greatest thing and what's the smallest thing in both lists that they have in common. Moving on to the next page, I'm going to go over number 2, and that will end this video. The second part of this lesson will go into the prime factorization method. So this second problem here says Bill and Sue both work at night. Bill has every 6th night off, and Sue has every 8th night off. If they are both off tonight, how many nights will it be before they are both off again? And so when you look at this word problem, you have to be able to identify whether this problem is looking for multiples of 6 and 8 or divisors of 6 and 8. And if a person is off every 6th night, that means they're off night 6, and they're off night 12, and they're off night 18. And the numbers that I'm saying to you are multiples of 6, every 6th night and every 8th night. And so when I want to know when will be the next night they are off again, I need to compare multiples of 6 and multiples of 8. So multiples of 6 are going to be this person, Bill, is off night 6, he's off night 12, he's off night 18, he's off night 24, he's off night 30, ... And I'm just listing multiples of 6. Multiples of 8, Sue is off night 8, and then she's off night 16, and she's also off night 24. That's 8 times 3. 8 times 4, she's off night 32, and so forth. And if I have a common multiple, I can stop. If I don't have a common multiple, that just means I need to keep adding to my list, adding to my sets. But when I look for the next night they're both off again, that is going to be the least common multiple. So when I compare these two sets, the smallest multiple that these two sets have in common is 24. So the least common multiple of 6 and 8 is equal to 24. So they are both off again on the 24th night. And again, I used that set intersection method to calculate that least common multiple.